Hello everyone, this is our session 4 on matrices. Okay, so we were doing the adjoint method for finding the inverse of a matrix. Then we started with exercise 2.2. Okay, so we are on the first question, find the cofactors of the following matrices, right? So that was our first question. We had done one sum from that. Let's go to question 2. Find the matrix of cofactors of the following matrices. So the procedure is same. You have to find the cofactors and then make a matrix of the same. Okay, so let us begin. Exercise 2.2, question 2. First one says, find the matrix of cofactors for the following matrices. So the first one is a 2 by 2 matrix. Let us take the matrix 1, 3, 4 and minus 1, 1, 3, 4 and minus 1. Okay, this is our matrix. So let us go through the process of finding cofactors. What do we have to do? We have to find the minor of each of the element and then we have to find the cofactor. So let us begin with A11. What is A11? It is 1. A12 is 3. A21 is 4. And A22 is minus 1. Okay. Let us find the minors of each. So M11 is equal to, how do we find the minor? Hide the row and the column in which that element lies. So one lies in the first row, first column, hide both of them. So the minor is minus 1. M12 is equal to first row, second column. So we have 4. M21 is equal to second row, first column, 3. And M22 is equal to, M22 is the second row, second column. So this is 1. Okay. After minors, we have cofactors. So how do we find the cofactors? A11 is equal to, I'll just write the formula once more and then you'll remember it. I plus j, so that is into its minor. So that was equal to minus 1 raised to 2 is 1 and M11 remains the same. So remember, when addition of I and j is an even number, answer remains the same, cofactor remains the same. When the addition is an odd number, then the sign changes. So A12, now the sign will change, so it will be minus 4. A21 is equal to sign change minus 3 and A22, no sign change, so answer will be 1. Okay, in the end, what do we have to do? Write the matrix of cofactors. So matrix of cofactors right? So the first element A11 minus 1, A12 minus 4, A21 minus 3 and A22 1. Okay, this is our matrix of cofactors for the first sum. Let's go to the second one. So the second one is, it's a 3 by 3 matrix. 1 minus 2 is 0. Okay, 0, 1, 3 and 2, 3 and minus 5. Okay, this is our second matrix. It's a 3 by 3 matrix, so we have 9 elements of which we have to find the minors. So I'll directly begin with finding the minors. Okay, let us start with minors. So M11 means first row, first column, first element. Okay, hide them, find the value of the determinant. So when you hide the first one, first column, you are left with this determinant over here. Okay, so what will be the answer? Minus 5 minus 9, that is minus 14. Okay, then next one, M12, that is first row, second column, M12. Okay, So M12 is first row, second column. When you hide that, then you're left with these two and these two elements here. So let's find the determinant value. -2 into -5 is 10. 10 minus 0 is 10. Okay, so M12 is 10. Then we have M13. Okay, so M13 first row, third column, right? So first row, third column, hide them. So you get -6 into, -6 plus or -0 is -6 itself. So M13 is -6. Okay, then next, so second row, M21, second row, first column, hide the second row and first column. So when you hide the second row and first column, the determinant value will be 0 minus 6, that is 6. Okay, -6 over here. Then M21, then M22 is equal to second row, second column, -5 minus 0, answer is -5. M23, that is second row, third column. So we have 3 minus 0, that is 3. Okay. Now next one, M31, third row, first column. Okay. So the determinant value is 0 minus 2, that is -2. M32, third row, second column. So we have 3 minus of minus plus 4, that is 7. And M33, last element, third row, third column. So 1 minus 0, that is 1. Okay, so these are minus. We are left M32, third row, second column, 3 minus, yes. Okay, now cofactors. So what do we have to do for cofactors? I said I plus j is even, then the answer remains the same. And if it is odd, then we change the sign. So let us begin. A11, I plus j is even, so number remains the same. A12 will be, the addition is odd, so answer will become minus. A13, addition is even again, so answer remains the same. A21 is equal to plus 6 because it's a odd number. A22 is equal to -5, same, because addition is even. Then A23 is equal to, addition is even, so odd, so it will be -3. Then A31, addition is even, so the answer remains the same. A32, addition is odd, so answer will change its sign, -7. And A33, okay, so this is 6, so the answer will be same, 1. Okay, now let us put it into a matrix form. So all the numbers in a matrix. So we have A11, that is -14, A12, that is -10. Then we have A13 -6, A21 6, A22 -5, A23 -3, A31 -2, A32 -7, and A33 1. So this is our matrix of cofactors. Okay, I think cofactors is clear now. So we can move to the next sum, or you could say next question. It says find the adjoint. So let us go to find the adjoint. So question 3, find the adjoint. So procedure is same. We find matrix of cofactors. Okay, so we'll go run through it fast, and then we can we have to take the transpose. So when we take the transpose, that is the adjoint. Okay, let us begin with the first one. We start with a 2 by 2 matrix, 2 minus 3, 3 and 5. This is a 2 by 2 matrix. Okay. Remember for the adjoint, the formula is 1 upon determinant of A multiplied by, sorry, that is the formula for the inverse. Let us begin with the adjoint. So again, I'll write the minors for a 2 by 2 element a matrix. Minors are very simple. M11 hide the row and column, so you get 5. M12 first row second column, so 3. M21 second row first column, so -3, and M22, okay, that is equal to second row second column, so we are left with 2. Okay, this is our minus. Then our cofactors. Okay, so what will be the cofactors? A11 is equal to, addition is even, so answer remains same. A12 addition is odd, so answer will change its sign. A21 again answer will change its sign, and A22 answer will not change its sign. Okay, matrix of cofactors. Okay, so matrix of cofactors, right? Let us put it in matrix form. 5 minus 3, 3 and 2. Okay, and then what is the last step? Adjoint of this matrix. Adjoint of, if I call this A, so we can write this as adjoint of A, okay, is equal to, what do we do? Row becomes column, so 5 minus 3 and 3, 2. Okay, this is your adjoint of A. Let us go to the next one of the same question, second one. So the second one is a 3 by 3 matrix. So we have 1, minus 2, minus 2, minus 1, 3 and 0, 2, 5 and minus 1. Okay, this is a 3 by 3 matrix. What do we have to do? Find their minors, then their cofactors, and then matrix of cofactors, and then the adjoint. So let us begin with the minors. M11 is equal to, first row first column is hidden, so 3 into minus 1, minus 3 minus 0 is minus 3. M12 first row second column, so minus 2 into minus 1, that is, when I take first row and the second column, okay, you have to hide these. When you hide this, the determinant will be minus into minus plus 2, 2 minus 10 plus 10, that is 12. So M12 is 12. Then M13, okay. So M13, what do we have to hide? M13 means first row and third column has to be hidden. So first row and third column, first row and third column has to be hidden. So the determinant is minus 2 into 0 is 0, minus of minus plus 2 3 is 6. So M13 is 6. Okay, then next M21, second row, first column. So what are we to hide now? What are we to hide? Second row and first column. So the determinant is minus 1 into minus 1, that is plus 1. So 1 minus 0, that is 1. So M21 is 1. Okay, then M22, second row, second column. So what will we hide now? Second row and second column, right? So then we have 1 into minus 1, that is minus 1, minus of minus plus 4. So minus 1 plus 4, answer is plus 3. Okay, this is M22. Now M23 is second row, third column. Okay, so second row, that is this, and the third column has to be hidden. So what are we left with? 1 into 0 is 0. 0 minus 2 is minus 2. So M23 is minus 2. Okay, then M31 is equal to, that is third row, first column. So we will hide now third row and first column. So third row and first column has to be hidden. Okay, so the determinant will be minus 5 minus 6, that is minus 11. Okay, M31. Then M32, that is third row, second column. So we have third row and the second column has to be hidden. So what are we left with? 1 into 5, that is 5. Minus of minus plus, 5 plus 4 is 9. So M32 is 9. Okay. And the last one, M33. So third row and third column. So this is your third row and your third column, they have to be hidden. So we are left with 1, minus 1, minus 2 and 3 as a determinant. 3 minus 2 into 1 is 1, 2. So 3 minus 2, 1. So M33 is 1. Okay. These are our minors. Now what will we do? Find the cofactors. Okay, so cofactors is simple. I said add I plus j. If it is odd, then it will be negative, and if it is even, then it will be positive. So let us begin. A11, which will be the same. So minus 3, A12, it is odd, so sign will change. A13, which is even, so it will remain the same. A21, odd, sign will change. A22, sign will not change. Okay, then A23, sign will change, so it will be positive 2. A31, sign will not change. A32, again sign will change because the addition is odd, so minus 9. And A33, sign will not change. Okay, matrix of cofactors. Right, so what will be the matrix of cofactors? Let us put all these numbers in order. So minus 3, minus 12 and 6. Then we have minus 1, 3 and 2. Then we have minus 11, minus 9 and 1. This is our matrix of cofactors. Okay. Now what do we have to do next? Matrix of cofactors is ready. Adjoint of A. So adjoint of A. You can always name the matrix. We've not named it here, so we're just putting the name. Then adjoint of A is equal to, what do we have to do? Matrix of cofactors has to be transposed. So row becomes the column and column becomes the row. So let us write this down. It will be minus 3, minus 12 and 6, minus 1, 3 and 2, and minus 11, minus 9 and 1. This is your adjoint of A. Okay. I hope this part is clear. It's just a transpose. Let's go to the next question of this exercise, question 4. So question 4 says that if A is a matrix, verify that A adjoint of A is equal to adjoint of A into A equal to determinant of A into I. I have done this type of sum previously, but I'm doing this again with a 3 by 3 matrix. So let's verify this. A is equal to 1, 3, 1, minus 1, 0, 0, 2, minus 2 and 3. Okay, this is your matrix. What do you have to verify? A multiplied by adjoint of A is equal to adjoint of A multiplied by A is equal to determinant of A into I. Okay, this is very simple. Same procedure, you have to find the minors. then the cofactors, and then its matrix. And then the last step is adjoint of A. Okay, so let us begin. Minors will be M11, M12, M13. Okay, M14, sorry, M31, M21, M22, M23, M31, M32, and M33. Okay, these are our 9 elements, and we are going to find their minors. Okay, let us begin. The first one, M11, first row, first column, 0 minus 0, that is 0. M12, first row, second column, 9 minus of minus plus, 9 plus 2, 11. M13, that is first row, third column, 0 minus 0, again 0. M21, okay, second row, second column, so 3 minus 2, that is 1. Okay, M21 is second row, first column, so minus 3 minus 0, that is minus 3. So we made a mistake here. Yeah, M21, second row, first column, minus 3 minus 0, so answer is minus 3. M22, second row, second column, so 3 minus 2, that is 1. M23, M23 will be second row, third column, so 0 minus of minus plus, and that will be 1. M31, third row, first column, okay, so it will be 2 minus 0, that is 2. M32, third row, second column, so minus 2 minus 6, that is minus 8, okay, and M33, last row, last column, so 0 minus of minus plus 3, that is 3. Okay, these are our minors. Let us find the cofactors now. Okay, so let me write the cofactors. A11 is equal to 0, remains the same. A12 changes the sign. A13 will be same. A21 is equal to, changes the sign. Then A22, no change of sign. A23 is equal to, changing the sign. A31, no changing of sign. Okay, A32, again change the sign. And A33, no changing the sign. A33 will remain the same. Okay, from the cofactors, let us write the matrix of cofactors. So matrix of cofactors is equal to, let us put it in the tabular form, 0, 3, 2, minus 11, 1 and 8, 0, minus 1 and 3. Let us just verify it once more. So we have 0, minus 11 and 0, 3, 1 and minus 1, 3, 1 and minus 1, 2, 8 and 3. Yes, so this is matrix of cofactors. Adjoint of this will be, adjoint of A is equal to transpose of this matrix. So let us make the column as the row, 0, minus 1 and 3. Okay, so your columns have become the row and your rows have become the column. This is adjoint of A. Okay, what is the verification now? A into adjoint of A. Okay, so let us begin. A into adjoint of A into adjoint of A. is equal to, let us write the A matrix first. 1 minus 1, 2, 3, 0 minus 2, and 1, 0, 3. This is your A matrix. Your adjoint matrix is on top. Let us put that down. And 0, minus 1, and 3. When we multiply the two matrices, the answer we get is 11, 0, 0, 0, 11, 0, and 0, 0, 11. Okay, this is A into adjoint of A. Okay, same way you will find out adjoint of A into A. Okay, which will be, you write the adjoint matrix, the A matrix, okay, which is equal to the answer matrix. So let us put the adjoint matrix first now. 0, 3, 2, minus 11, 1, and 8. This is then 0, minus 1, and 3. Okay, and then the A matrix, 1, minus 1, 2, 3, 0, minus 2, and 1, 0, and 3. Okay, so when you multiply this in this order also, we get the same answer. Okay, and the last one, the verification is determinant of A multiplied by an identity matrix. Okay, so let us find the determinant of the matrix A. Okay, so here we have the matrix A. Let's just write this down here. 0, minus 2, 1, 0, and 3. Okay, first we'll just find out the determinant of A, and then we can multiply it with the identity matrix. So determinant is equal to 1 multiplied by 0 minus 0, that is 0, minus of minus will become plus 1. Okay, 9 plus 2, okay, plus 2 multiplied by 0. Okay, so we're getting the answer is 11. Now the determinant value is 11. Okay, so determinant of A multiplied by I will be 11 multiplied by an identity matrix. Right, so the answer will be 11, 0, 0, 0, 11, 0, and 0, 0, 11. It means that we have verified that A into adjoint of A is equal to adjoint of A into A is equal to determinant of A multiplied by identity matrix. Okay, I hope this part was clear. We've done this for a 2 by 2 matrix. Similar manner we do it for a 3 by 3 matrix. Okay, the last question is to find the inverse. Okay, so the procedure is same. You have to find the cofactors, and then you have to make the matrix of cofactors. After that, we give the inverse of that, transpose of that, and then you have to multiply it with the determinant, reciprocal of the determinant. Okay, so I'll just solve one sum of that question, and we'll be done with this exercise. I'm taking the third sum. Okay, the third sum is a 3 by 3 matrix, 1, 0, 0, 3, 3, 0, 5, 2, and minus 1. The question is find the inverse of this matrix by adjoint method. So we'll take this as matrix A. What is the procedure? Find the minors, then the cofactors, matrix of cofactors, then its transpose, and then multiply it with determinant of A. Very first step to check if inverse exists, what do? Find the determinant of A. So determinant of A will be equal to 1 multiplied by minus 3 minus 0 minus 3 minus 0 multiplied by whatever will be in the bracket will be 0. I'll still write it, minus 3 minus 0 plus 0 multiplied by 6 minus 15. Okay, so both these terms are 0. We are left with minus 3. So determinant of A is -3. That means the inverse exists. Okay. Then let's write the minors over here. -3, -3, and -9. Okay. M21, 21, 22, and 23 is 0, -1 and 2. And M31, M32, and M33 is equal to 0, 0, and 3. Okay. These are your minors. What will be the cofactors? Only change the signs wherever you get the odd addition. So A13, A11 remains the same. A12 will change its sign. A13 will not change. Okay. Then A21 will change, so, but it's a 0, so we put it as 0. A22 will not change. A23 will again change to a minus sign, so -2. A31 is equal to 0. A32 is equal to 0. And the last one, A33, okay, I'll write it here. A33 is equal to 6, addition is 6, so the answer will remain the same, 3. Okay, let us make the matrix of cofactors first. The matrix of cofactors will be -3, 3, and -9, 0, -1, -2, 0, 0, and 3. Okay, this is your matrix of cofactors. Adjoint of this matrix, so we write adjoint of A is equal to transpose of this matrix. So -3, 3, -9, 0, -1, -2, 0, 0, and 3. Okay. This is your adjoint of A. Determinant value we've already found out. So what will be A inverse? A inverse is equal to 1 upon determinant of A multiplied by adjoint of A. So just put in the determinant and write your adjoint. Okay. I think we've had enough practice of finding cofactors and minors, and so adjoint method seems to be simpler compared to the row column transformations, because there sometimes you might require many transformations and sometimes you might be done in 1 or 2 transformations. Okay. Hope you have understood this exercise. In the next session, we will do miscellaneous 2A. Okay. I will only go through the difficult problems. Easier ones I expect you to solve. But if you have a doubt in the same, you can ask me or mail to me. Thank you very much.